This atom looks perfectly normal, but is it neutral, positive, or negative? In organic chemistry, that one detail can change everything. Two molecules can look almost identical, but a hidden charge on one atom can completely change how the reaction behaves. In this video, you'll learn what formal charge is, how to assign it to atoms, and how bonding patterns signal whether an atom is neutral, positive, or negative. Formal charge is a way to track how many electrons an atom is effectively responsible for inside a molecule. An atom is neutral when the number of electrons it's assigned in a structure matches its valence electrons. Carbon has 4 valence electrons, nitrogen has 5, and oxygen has 6. These numbers set our baseline. When carbon forms 4 bonds, it contributes 1 electron to each bond. That's 4 electrons in total, so its formal charge is 0. At this point, it's tempting to just count bonds. But what really matters is electrons contributed, not just how many lines you see. So far, we've covered valence electrons and how matching that number leads to a neutral formal charge. Curious how much you're remembering? Your personalized practice test, flashcard set, and study guide are all waiting for you. Just tap the link now and keep watching. Future you will thank you. Now, let's look at what happens when carbon doesn't follow the 4-bond pattern. With 3 bonds and 1 unpaired electron, carbon still contributes 4 electrons, so it remains neutral. If carbon contributes only 3 electrons, it falls 1 short and carries a positive formal charge. Add a lone pair, and carbon now contributes 5 electrons, 1 extra, giving it a negative formal charge. Nitrogen follows the same logic as carbon, but it starts with 5 valence electrons instead of 4. 3 bonds and 1 lone pair gives nitrogen 5 contributed electrons, which makes it neutral. 4 bonds mean only 4 electrons are contributed. Since nitrogen has 5 valence electrons, it's 1 electron short, making it positively charged. 2 bonds and 2 lone pairs add up to 6 electrons. Nitrogen now has 1 extra electron, which gives it a negative formal charge. Oxygen starts with 6 valence electrons, so its neutral state is 2 bonds and 2 lone pairs. Across these atoms, the rule is consistent. More bonds than expected lead to a positive charge, while extra lone pairs lead to a negative charge. Sulfur behaves the same way as oxygen, because they share the same valence electron count. Always compare electrons contributed to valence electrons and never assume charge from appearance alone. To sum it up, formal charge comes from comparing contributed electrons to valence electrons. Match means neutral, fewer means positive, more means negative. This skill helps you predict how molecules react and where chemistry happens. Now that you've watched the video, let's see how much you remember. Head to the link in the description, where you'll find Quizlet content made just for you.